Hi all, good evening. So today we shall begin with composition and structure of atmospheres. Composition and structure of atmosphere. Okay. Is this topic is in 6th, 7th and 11th NCRTs. Okay. Anjali, we'll see all these things later, ma'am. Don't worry about it. Okay. Because we have all those topics. Okay. So now, when we talk about composition, okay, composition. See, guys, atmosphere is made up of three things. Okay, please listen. I'll give time and then you can write. Atmosphere has gases. Atmosphere has water vapors. And atmosphere has dust particles. So there are three things: gases, water vapor, dust particles. When I say gases, we are talking about nitrogen, oxygen, carbon dioxide, etc. Okay? When I talk about gases, atmosphere includes nitrogen, oxygen, carbon dioxide, etc. Now you see, now when I consider the gases itself, fine. Oxygen, see, entire atmosphere is for 1600 kilometers. I hope you recollect. Entire atmosphere is for 1600 kilometers. Out of this, oxygen is approximately in between 100 to 120 kilometers only. Okay. Oxygen is not present throughout the atmosphere. Oxygen is present only 100 to 120 kilometers. When you talk about carbon dioxide, it is present only till 90 kilometers. That means gases are not present everywhere. Okay. There are only till a particular height gases will be present. Based on this, what we normally see is Earth is divided into two layers. This is 0, this is 80 kilometer, and this is 1600 kilometer. Okay. Now 0 to 80 kilometer is called as homosphere. 0 to 80 kilometer is called as homosphere. 80 to 1600 kilometers is called as heterosphere. Fine. 0 to 80 is called as homosphere. 80 to 1600 is called as heterosphere. Now, what is homosphere? What is heterosphere? You see, now I will take, gases at different places. Okay, gases at different places. Now, when I take gases at different places, In homosphere, we normally observe 78% nitrogen, 21% of oxygen, okay, 0.09% of argon, like this, at different layers. Anywhere you take 0 to 80 kilometers, composition will be same. Composition will be same. Okay, composition will be always same. When it comes to 80 to 1600 kilometers, okay, 80 to 1600 kilometers, then if I take different areas, okay, one I may get nitrogen more, another I may get oxygen more, another I may get hydrogen more. Okay, so different layers will have different gases. That is called as a heterosphere. Okay, homosphere, homosphere, homosphere normally is from 0 to 80 kilometers. Okay, homosphere includes, we call it as troposphere, we call it as stratosphere, we have mesosphere. Okay, we have almost three layers in homosphere. What are the three layers? Troposphere, stratosphere, mesosphere. And in homosphere, composition is almost same. Okay, homosphere means composition is same. This is what you should be aware. Guys, I am writing only three gases: nitrogen, oxygen, argon, carbon dioxide. You will also have hydrogen, xenon. Many gases are there. But I am just writing only 3, 4 for our references. So if I have not written, don't think it's not there. Okay? This slide will be important from prelims point of view. So please make a note of this. Heterosphere is from 80 to 1600 kilometers. Okay. Guys, composition is same. Basically means, please don't get confused. Don't be in a hurry to derive things. Okay. Composition is same means, anywhere if I take 1 liter of air, you will have 78% of nitrogen, 21% of oxygen, 0.09% of argon. Okay, composition is same. Basically means percentage wise, anywhere you take, nitrogen will be 78%, oxygen will be 21%. Okay, so that is how it is present, and beyond that some gases are not there. Fine. Why it is not there? There is no answer. Some gases are present only till a particular level. Okay. So life doesn't exist in other planets because there is absence of air. In ours, it is there because of multiple reasons. So let us look only in, UPSC point of view. 80 to 1600 kilometers basically means, okay, we are talking about thermosphere. Okay, thermosphere. And different layers will have different composition. Okay, write only this much, is nothing beyond this. I'll come to troposphere and all, Puja. One after the other will take. Guys, before you ask questions like, let's wait. Uh, I have to deal. I didn't teach you completely, right? I'm just going one after the other. Clear? Is this done? Nilanjana, I'll explain you ionosphere, exosphere, and all. As of now, think only about this points. Okay. See, guys, after this, we'll see the next one. That is about water vapor. See, guys, the other term for water vapor is moisture. Okay. Now, water vapor, if you take 90% of water vapor is present within 3 kilometers. Okay, 90% of water vapor is present within 3 kilometers. 99% of water vapor is present within troposphere. These are all facts important, guys. Okay, 99% is present within troposphere. Troposphere basically means we are talking about 8 to 18 kilometers. Okay, 3 kilometers from the surface, guys. 3 kilometers from the surface of the earth. Okay, within 3 kilometers from the surface of the earth. Okay, next is normally we say dry air means less moisture. If water vapor is less, we call it dry air. If we use the term moist air, okay, moist air basically means more or saturated moisture. That means maximum moisture is there. Moist air is basically more or saturated moisture. Okay, see, guys, In future, when I talk about dry air, moist air, cold air, warm air, okay, don't get confused. Dry air means in that water vapor is less. Moist air means in that water vapor is more. This is the case, okay? Please don't get confused that cold, dry, cold, warm, all this don't get into the debate. So what is the basic condition here? Dry, dry air can be cold also and it can be hot also. Okay. Moist air, moist air can be cold also, can be hot also. Okay. See guys, see guys, basically if I try to say dry air and moist air, just remember it is associated only with water vapor. Okay. How and all you forget. It depends upon water vapor. That's it. Okay. Now you see, when we talk about when we talk about dry air, dry air is heavier compared to moist air. Okay, this is the most important point. Okay, dry air is heavier compared to moist air. Okay. This I'll explain. You see, I will have iron. Okay, 1 kg of iron. Half kg iron. Pooja, did I talk about cold air or did I talk about dry air? You tell me. I told you don't get confused with respect to cold, dry. Okay? So please see what you are reading. Everyone. Like, why I'm telling you this is you get confused unnecessarily. That's why I'm telling you. Dry is different, cold is different. Moist is different, warm is different. Okay, I will reduce all your confusions. First see one after the other. If I'm writing dry air, please read it as dry air. If you read something else, you get confused. Half kg iron, half kg cotton. Okay, now guys, uh, density wise, if I said density, heavier, like if we hit, which one will have more impact? Only iron will have more impact. Cotton and iron will have more impact. Correct? So here can I say iron is greater compared to cotton and this. Good. Now you see, 1K here, you see 78% nitrogen, 21% oxygen, okay, 0.09% of argon you have. Now what is happening? I am replacing these by moisture. Moisture means what? Water vapor. Moisture means what? Water vapor. And what is this particular thing? 78% of nitrogen, 21% of oxygen, and all will be there. You see, water vapor is replacing nitrogen and oxygen. Okay, nitrogen is heavier compared to water vapor. Nitrogen is heavier compared to water vapor. So moist air will have less weight compared to dry air. Okay, now you think and tell me, when will clouds form? When air rises or when air descends? You tell me, when will clouds form? Whenever air rises. Okay, to form clouds, do you need water vapor? Do you need water vapor? Yes. So if moist air is heavier, then moist air sinks. It doesn't rise. And if moist air doesn't rise, no clouds are formed. Okay. So remember the basic fundamental thing. This line can be asked. No one will ask you explanation of this. Okay. Why no one will ask? The only thing they will ask is, dry air is heavier compared to moist air. I am giving explanation only for your satisfaction. Okay. See guys, did you get this particular point now? Where is water vapor present? 90% of water vapor is present within 3 kilometers. 99% is present till 8 to 18 kilometers. Okay. So in total, water vapor is present mostly till 99, like mostly in troposphere. That is, in this I will have 90%, in this I will have 9%. How water vapor is replacing nitrogen? See here, when we heat, water vapor will come and it will remove nitrogen. Okay. Yeah, Hariharan, what is the doubt? Water vapor is lighter compared to nitrogen and oxygen. So once water vapor comes in, nitrogen and oxygen will be removed. Okay. See how dry air is heavier? This is the concept. Because moist air has water vapor is lighter compared to nitrogen and oxygen. Okay. I'm not talking about heavier means in weight, ma'am. I'm talking with respect to density. Okay, because both are 1 kilos. It's not about weight. It is about density. How is it removing? Okay. You see this one? See, I have water. Okay, I have water. You heat the water. Water vapor will come. Okay, water vapor will come. Now what I'll do, I'll take this air. In this air, I will have water vapor. Is this clear? No, ma'am. Density is not in terms of water vapor. Density is in terms of, like, mass per unit area. Next is, you saw water vapor. Okay. Can you people tell me now here? I want you to tell me, if there is more water vapor, you tell me, does water vapor absorb? Does water vapor absorb sun's rays, and does water vapor absorb sun's rays and earth's rays? Yes or no? Yesterday, what did you learn? If you say no, you have not revising at home. You tell me, if it is absorbing both, you tell, will it increase? Will it increase the temperature? Zarana, not only earth rays, even sun's rays. Please try to read. Read and come to class. Yes. If it increases temperature, so you tell me, if I have more water vapor, that means, can I say atmosphere will be more hotter? If I have more, guys, okay, sun's rays is not reflected by water vapor, guys. Sun's rays is reflected by clouds. That's what I'm trying to tell. Some people, you're not studying at home, you are simply raising the doubts, because all concepts would not be clear to you if you are not reading at home. Okay, you see, if you have more water vapor, it absorbs sun's rays also, it absorbs earth's rays also, and that area will become hotter. Okay, so water vapor absorbs. I want you to write this point. Water vapor absorbs solar insolation and terrestrial radiation and becomes hotter. See, guys, what is the value that I wrote? The value that I wrote is, most of the water vapor is present within troposphere. That statement also you write. Most of the, this is also prelims question. Most of the water vapor is present within troposphere. Okay, most of the water vapor is present within troposphere. Terrestrial means earth radiation. Anbu, what did you read yesterday? You tell me. Yesterday you attended. Terrestrial means earth. Yes. Another point, guys. Lower troposphere has more water vapor compared to higher troposphere. Do you all agree with me, guys? Because 90% of water vapor is present within lower troposphere. Yes. Hmm. Yes, within 3 kilometers. Troposphere, I'll teach you now. I'll teach you troposphere. Okay? Sorry, it is not color insolation, it is solar insolation. Okay? Yeah. Why just now I told no? 3 kilometers you will have 90%. Oh my God. Okay. You people, okay. You have some confusion. I'll tell you guys. You see, Earth is there till 3 kilometers. You have 90%. Till 8 to 18 kilometers, you have 9%. Okay. So 90% is more compared to 9%. I hope now it is clear. That is the reason lower troposphere will have more compared to upper troposphere. Okay, thank you. Next, third aspect that we have is dust particles. Dust particles. Yeah, you remember my numbers, that's more than enough. Everyone for 2 minutes understand this guys. Dust particles. Okay, now you see, uh, normally if you are traveling from vehicles and all, you get some smoke particles, small particles. Similarly, uh, you will also observe that when we consider, like advertisements, if you have seen, people who go out and come, they take a white paper and wipe, you can see lot of particles on that. Okay, so those are dust particles. And why? Okay, let us say you have mud. What we do, I stamp. Okay, I, play with it. So what happens? Dust rises. These are all dust particles. If you are closer to the ocean, okay, if you are closer to the ocean, if you are sitting in the beach, don't enter into the water, you just sit in the beach. When you sit in the beach, when waves come and hit the shore, okay, some small salt particles sit on the surface of the hand. If you come out and clean, you can see some salt particles. You may feel, I didn't go into the ocean. Why do I have salt particles? The reason is, when waves come and hit, some salt particles are thrown out. Similarly, in atmosphere also, we will have few minute salt particles or dust particles. Okay, now why is this important? These dust particles, they have a very important role to play. The first most important thing is about light, guys. Okay, so what do they do? Whenever we see, suddenly when I turn off the lights, okay, when I turn off the lights, my eyes will become, blank. Everywhere it would be dark. After some time, I can see that light will be there. Okay, that is because of scattering of light by dust particles. What do dust particles normally do? They scatter the light. So when they scatter the light, you can see little bit. I'll tell other way around. After sunset, okay, once sunset occurs, you can still find that light will be there for a while. Before sunrise, light will be there. That is due to dust particles playing a role. This is one important aspect of dust particles, that is, dust particles help in scattering of light. Okay, please don't ask any question till I complete this, then I'll give you time, because this is little confusing. I want you to listen carefully. Okay, scattering of light, this is very, very important. Second, in other terms, if I want to tell you guys, if I take a glass of water, okay, put sand into it, can I say most of the sand particles will settle down? Most of the sand particles will settle down, and few particles will be floating. Have you seen? Few particles will be floating. So those floating particles in the water, okay, is because the particle size is small. The particle size is very, very small. Similarly, in air also, you will have very minute particles, okay, that are dust particles. Now, what is this? These dust particles help in the formation of clouds, rainfall, clouds, everything. These dust particles are very, very important. Now, I will tell you, you see, when do you get rainfall? Okay, when do you get rainfall? Whenever water vapor, whenever water vapor becomes water. This process is called as what? Condensation. Okay, this process is called condensation. But water's property is that, okay, what is the property of water? Water's property is that it will not become water vapor to water. It will never become water vapor to water easily. What it wants a medium. A medium is required. A cold surface is required. I'll give an example. If I keep this bottle in a refrigerator, after some time, if I remove it and check, I will observe that when the bottle is cold, on this bottle, water droplets would be there. Okay. Now, whenever the wind blows over a car, whenever the wind blows over leaves, whenever the wind blows over gate, land, anywhere, if the surface is cooler, you can see water droplets. Winter season, you might have seen leaves, like, dew, we call dew. Everywhere the water vapor would have converted into water. Okay, so for water vapor to get converted into water, it requires a medium, it requires some object. Land and all, you will have some object, but for clouds to form, I repeat, for clouds to form, clouds are in the air, correct? In the air, the only particles which provide cooler surface, I repeat, in air, the only particle which provides cooler surface for water vapor to become water is dust particles. Okay, dust particles. That is property, dew, 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 right? That is property of the water vapor. You see, I'll just show you here. The moment you have dust particles, okay, let me say I am in Delhi. In Delhi, when I have winter season, early morning, land is very, very cold. Okay, now I have lot of dust particles. All these dust particles will also be cold. If all the dust particles are cold, water vapor would condense around the, yes, conduction, very good, around the dust particles to form fog. Have you seen this in Delhi or in winter season? Will you get fog? Will you get fog in winter season? Yeah. Now, have you heard in Delhi, Punjab, Haryana people, stubble burning is one of the main reason for most of the problems? Yes or no? Have you heard? Yes. Now, what Punjab and Haryana does this? Punjab and Haryana puts lot of dust particles. You tell me, if you have more dust particles, will you have more fog? If you have more dust particles, will you have more fog? Yes or no? If fog increases, can you tell me, will it allow sun's rays to penetrate or it doesn't allow sun's rays to penetrate? Doesn't allow. Have you heard when fog is more, visibility reduces? You might have heard lot of accidents happen. Have you heard? Lot of accidents happen when fog is there. That means sun's rays is not entering. Okay. Now you tell, if vehicles release the smoke, smoke plus fog, will it become smog? No, fog is similar to cloud. It doesn't absorb easily. Guys, smoke plus fog leads to smog. Do you? No, no, no. Gia, not like that. Not like that. You see, area with less dust particles will have less fog. Okay, area with less dust particles will have less fog. Okay, I'll tell you few things right now. You tell me, if at all dust particles reduces, if dust particles reduces, can I say fog reduces? Yes, dust particles accumulate with fog. Yeah, you tell me now, will fog reduce? Yes. Okay. How to reduce dust particles? How to reduce dust particles? Can I say, if I spray water in the air, okay, if I spray water in the air, will it settle all the dust particles? Yes or no? Yes. Yes. Or if I induce rainfall, can I say it will settle down dust particle? Delhi wanted to have artificial rains. Did you hear that? Delhi wanted to have artificial. Yes. Do you understand? Yes, dust settles down. If dust settle down, see guys, if there are two words here, guys. One is fog, another one is smoke. Delhi is very, very important, so understand it. Fog is formed due to, what are the two things that are required to form fog? Dust particles and dust particles and water vapor. Okay, smoke is coming from vehicles and industries. Okay, smoke is coming from vehicles and industries. Fog is due to dust particles and water vapor. Okay, so in Delhi, I want to reduce smoke also. I want to reduce dust particles also. Okay, this dust particles are coming from Punjab and Haryana. They are coming from Punjab and Haryana. That is the problem. Okay, that's why Supreme Court told one basic aspect, like, please stop stubble burning, or better you drop a nuclear bomb on Delhi because you are trying to kill us, right? So guys, what I want you people, no, Anjali, stubble burning is very wrong. Dust particles should not be released so much. Okay, over a period of time also, smoke and other things. Remember, stubble burning means basically you're burning the grass type of thing, right? It has a lot of carbon dioxide, and that also leads to pollution. So it's better not to go for it. Okay, because you see, you're all looking up to yourself as IAS officers. So when you are IAS officers, you should think about everything. Okay, so we should not say, okay, you could have done at some other time. No, you should talk legibly. Punjab and Haryana normally shift from, like, Kharif to Rabi. At that time, they burn the rice, like, crops leftover parts. That leads to problem. South India, stubble burning doesn't happen. Okay, this is a very good question. I'll tell you the aspect here. Normally, guys, in Punjab, Haryana region, they grow rice, they grow rice, and they grow wheat. Okay, they need to shift from rice to wheat. In South India, they grow rice and they grow rice. No need of shifting. So what do they normally do? Whatever is left over, they will put it on the ground. Okay, it helps as mulching. Whereas in Punjab, Haryana, they don't want to put it because it acts as weed. So what do? They remove it. Okay, actually growing rice itself is a problem. Okay, so now when they want to shift, this rice leftover parts, okay, they burn. This burning enters. Weed is unwanted plant matter. No, ma'am. They actually put it. They use it as fertilizers. Burning is very less. And even if they are burning, it's wrong. Okay? Even if they are burning, it's wrong. Actually, cultivating rice itself is wrong according to many people because of methane released. That you will study, don't worry. Huh. What else they can do? Good question. That should be used as biofuel, and it can be converted into bio capsules and all. This is your research. You should do research on it. What should the people of Punjab and Haryana do? government of Punjab and Haryana is actually trying to put up equipments which will collect these and convert them. But the problem is, to collect and convert it, they're asking farmers to pay, and farmers are not willing to pay. That is the problem. Within 8 to 18 kilometer, 99% of water vapor is present. Okay. There is no law against stubble burning, but it is not acceptable. Anyways, is this done? See guys, all these are good. You should debate, you should ask, you should question why we should not, why people are doing. This is how you get knowledge about this. Fog is fog is like a cloud. If you add smoke into it, it is smog. South India, it is less smog. South India burning is less. Okay. See guys, once this is done, next, structure of atmosphere. Structure of atmosphere. Guys, atmosphere is divided into troposphere, stratosphere, mesosphere, okay, thermosphere. Thermosphere is divided into two. One is called as ionosphere, another one is called as exosphere. Okay, so this is structure of atmosphere. Exosphere. Okay, now we'll take every layer and try to see guys, the bottommost layer is called as troposphere. Earth from zero till 8 to 18 kilometers. This entire layer is called as troposphere. Okay, this layer from the earth till 8 to 18 kilometer is called as troposphere. In troposphere, if I take A and B, okay, A is below, B is above. Layer closer to the earth will be hot. Layer above will be cold. Okay, in troposphere, as I move above, temperature decreases. Now, what are the reasons for this? What are the reasons for this? First reason is density. Density. Okay. Now you people tell me, do you recollect, due to degassing, when Earth was releasing the gases, most of it was held by Earth's gravity. Yes or no? Most of it was held by Earth's gravity. Yes. If most of it is held by Earth's gravity, can I say, can I say closer to the Earth, I have more particles, and as I move above, I have less particles. Okay. So because of this, we call here high density, high density, high temperature, or high pressure. If I go above, I will have low density, low temperature, or low pressure. Do you all agree with me? So here, A will be hot, B will be cold. This is the first reason. What is the second reason? Second reason is water vapor. Water vapor. Can you all tell me? Can you all tell me where will you have more water vapor? Where will you have less water vapor? Closer to the earth. Closer to the earth, you will have more water vapor. You will have less water vapor. Good. Can you people tell me now? Can you people tell me now? If you have more water vapor, will temperature be more or will it be less? More water vapor. Yeah. So, very good. Then, third point. You tell me, will there be conduction closer to the earth? Will there be conduction closer to the earth? Yes. So, can I say layers closer to the earth is hotter? Now my point is, I want you to think and tell me, if cold is above, hot is below, can I say cold is heavier and it comes down? Hot is lighter and it rises. Do you recollect? Yes. Will there be vertical movement? Huh. If there is vertical movement, can I say convection occurs? Convection occurs? Yes. Yes. Guys, in NCRT they say in troposphere there is convection. Is that statement correct? Yes. Yes. Now I want you to write down. I want you to write down. Now you write structure troposphere. Ma'am, I will discuss other layers, ma'am. Then you will get clarity. Okay? Don't come to conclusion. We just did troposphere. Right? What is troposphere? I want you to write down. This is See guys, whatever you are writing, okay, some people are asking previous year question discussion. Previous year question discussion to occur, first of all we need to complete few topics. As of now I have completed only basics, and today I have started atmosphere. UPSC never asks you directly question from one topic. This is not history polity where preamble, like 1857 revolt questions will come. Intermixing of questions will be there. So once a significant portion is done, you will get clarity. Then I will look at previous year question. As of now, wherever I tell this is important and wherever I'm making you to write notes, write that properly. Okay, and for those, I'm telling you again, slides when you get only the topics that I am writing down, you please read only that much. Okay, don't try to read the other printed one that is there. Okay, typed one that is there, that I'll cover over a period of time. As of now, your focus must be only on this. Troposphere. Okay, in troposphere we observe 90% of the gases, 99% of water vapor, almost 100% of dust particles. These three are important. And then within troposphere, with increase in height, temperature decreases because this is questionless. Okay, why can be a question. Below this, there is high density of air closer to earth, and as we move above, as we move above, density decreases. Guess quickly, if you want to take screenshot you can take. I'll move to next slide. Okay, can I move to next slide? Second 90% of water vapor is in lower troposphere, and it absorbs solar radiation and terrestrial radiation. Guys, you won't get any of this in NCRTs, guys. I am elaborating it just to ensure that questions are easier for you. Okay. Third, Earth is the major source of heat for atmosphere. Do you recollect yesterday we read Earth is the major source of heat for atmosphere? Layers closer to Earth will be warmer. Did you write this? Now, guys, do you recollect? I'm telling right from the beginning, troposphere height is 8 to 18 kilometers. Correct? I'm not telling one accurate. I'm telling it may spread from 8 to 18. So let us see why it is. Ma'am, solar insolation, solar radiation is one and the same. I told you from yesterday, both are one and the same. Zero, 30°, 60°, 90°. Guys, don't draw. Wait for a while. And then I want you people to draw this. Yes, let us say this is constant. Okay, this is constant. This is how it was in the beginning. Okay. Can you tell me 0 to 30? 0 to 30. Land will be hot or will it be cool? Land will be hot. Then can I say 60 to 90? You will have cold air. Cold? Yes. Not air, cold. Okay. This will be normal. Can you people tell me, if land is hot, air above the land, what is going to happen? Air above the land, what is going to happen? Will it expand or will it contract? Will it expand or will it contract? It expands. Good. You tell me now, if surface is cooler, okay, you tell me what is going to happen? Contracts. That means reduces. Can you all check here? Near the poles, it is reducing. Near the equator, it is expanding. Due to these two, can I say the height of tropopause will not be same? How does tropopause height look like? It will be 8 kilometer. It will be 13 kilometer. It will be 18 kilometer. So the height of troposphere will be, how much? Like, 8, 13, 18. Okay. I want you to tell me, guys, with the latitudes, you tell me, is their troposphere height changing or is it constant? With latitudes, is it changing or is it constant? Changing. Okay. You tell me now. Uh, if at all it is summer season, okay, if it is summer season, will land become more hotter? If it is summer season, will land become more hotter? Yes. Will it expand more? Will it expand more? Yes. In winter season, can I say land becomes cooler? Land becomes cooler. Huh. Will it contract more? Yes. Now my point is, I'll write a statement, you tell whether it is correct or not. Troposphere height is not constant. It changes with latitude and seasons. Is this correct? Guys, poll and all will do this, don't worry. Those are all very minute things. Focus on clearing the exam. Okay, that is more important. Okay, here, near poles, 8 kilometer, near equator, 18 kilometers. Okay, average is 13 kilometers. So many books say average height of troposphere is, 13 kilometers. Can you please write this down? Yes. In winter also, near the pole height decreases. Anjali, you're right. Remember, in winter, height will be very, very less. Because in winter, temperature will become minus 90 degrees Celsius there. Zarana, I didn't get the question. I'm sorry. I couldn't see. Okay. Please write this down properly. Akshay, cold air comes down. Again, it gets heated and rises. Okay. Answer is yes, ma'am. Okay, don't worry about it, ma'am. Zarana, don't worry about it. I'm telling, compared to equator, compared to poles, 30 to 60 degree will be like normal. Lakshmi, I'll discuss latitude, longitude before talking about atmospheric circulation. Yeah, Zarana, compared to equator and poles, 30 to 60 is normal. That's what I'm trying to tell. Yes, Dhruv, you're right. It reduces in winter near poles. It becomes maximum near equator. Okay, you're talking about 30, 60, 90. I'm taking it as reference, ma'am. I'm just taking it as reference. 0 degree, 30 degree, 60 degree, 90 degree. Mohan, no. Droughts and floods are different. This concept is different. Abhishek, it's opposite. Abhishek, it's opposite. It's not one way. Okay. Aditya, don't worry about the numbers of heat budget. Whatever I told you, that is more than enough. Only troposphere height is changing, ma'am, not any other layer. See, about other layers, I will be explaining further. Kennedy, don't think much about dry air, moist air, that thing. Consider it as a fact. Dry air, whoever has doubt with respect to dry and moist air, you see the class topic that once again. Else, just remember, dry air is denser compared to moist air. Okay, don't get into replacement and all. Kavita, optional and all, we can talk, ma'am. Like, when you, uh, if you are interested, later we can discuss those. These degrees are latitudes, Patan, not longitudes, latitudes. See, guys, one thing, what I have given, that you should focus, not more than that as of now. Remaining things we'll discuss. Okay, Lakshmi, you're right. Guys, my notes, all faculties try to say that their notes is enough. The same thing I would also say, because of experience of teaching, we know what all questions, what are the different languages that is expected from a particular topic, and that's why I'm writing it down as well, because when I explain and leave, okay, it is not like other subjects, guys. Polity and all, even if I speak something, when you go back and read, you get a proper thing. Geography is technical. Okay, if I explain something, you may write something else. I have seen lot of notes like that where students misinterpret and write. I don't want you people to do that. That is the reason I'm ensuring that in the class itself we are working it out. Okay. Gia, we can think of only doubt session now. Dhruva, I'm not an all India ranker. I'm just a UPSC faculty. Yeah. Is this clear? Everyone? Yes. Now, above troposphere, we have a layer called as stratosphere. Okay. Please listen to this completely. Then you ask questions. Okay. We have a layer called as stratosphere. And remember, atmosphere, whatever I'm trying to tell, is facts. Okay. And we don't know why it happens. We are assuming that this may be the reason. Okay. Because rainfall occurs. In India, monsoon rain occurs. That is fact. We are trying to see what is the reason. Earth rotates 24 hours it takes. It revolves around the sun. These are all facts. Why it is happening is our own understanding of that phenomenon. So, never ever come to conclusion with this. Facts are important, not concepts, reasons. Okay. Now, there is a layer called a stratosphere. Now, if this is Earth's surface, let me take 8 to 18 kilometer till 50 kilometer. So, in this range, I have a layer called as stratosphere. In this layer, we have ozone content. Okay, see guys, in this layer also you have nitrogen, oxygen, nitrogen 78%, oxygen 21%. But in this layer, additionally, one gas is there, that is ozone. Okay, and how is ozone formed? Oxygen plus O minus, when it absorbs UV radiation. So when it absorbs UV radiation, normally ozone is formed. Okay. Normally ozone is formed. Now, when I look at stratosphere, when I go to stratosphere, when I check in stratosphere, what I found, lower stratosphere has thick layer of ozone. Okay. And upper stratosphere has thin layer of ozone. This is what we observe. Okay, this is what we observe. Upper stratosphere has thin layer, lower stratosphere has thick layer of ozone. Now you see, sun's rays is coming from above. Both ozone is good now. Stratosphere ozone is good, troposphere ozone is bad. Okay, now guys, I will write this as A layer, I will write this as B layer. A layer, B layer. Now I want to ask you a very simple question. I will take a small tumbler, fill it with water. I'll take a big tumbler, fill it with water. I will heat small tumbler. I will also heat big tumbler. I am giving same heat. Can you tell me which one will become hot soon? Small or big? Small. Good. Small will be hotter. This will be cooler. Good. You tell me here, A is small layer, B is big layer. Which one will become hot sooner? A will become hot, B will be cold. Okay. Guys, do you recollect I gave you a statement? If cold air is below, hot air is above, no vertical movement. Do you all recollect that particular point? Now you tell In troposphere, was there vertical movement of air? In troposphere, was there vertical movement of air? Yes. In stratosphere, do you have vertical movement of air? Yes or no? No. Second, you tell me, will you have more clouds in stratosphere or less clouds in stratosphere? Will you have more clouds in stratosphere, less clouds in stratosphere? Stratosphere will have less clouds. Remember, why water vapor is less, ammonia, liquids are less. Okay. You tell me, when a flight is moving like this, if air is moving vertically, is it good? Or if air is not moving vertically, it is good? You tell me. If air is moving vertically, good. Not moving vertically. If air is moving vertically, it will disturb. If air is not moving vertically, it will go easily. So you tell me second one. If there are less clouds, then can I say it is good again? Yes. So which layer is good for aircraft movement? Which layer is good for aircraft movement? Stratosphere. Okay. Remember this point. In India, we go in troposphere only this. But in US and all, they go in stratosphere. In India, we go because India is 18 kilometers. Is India closer to equator? Is India closer to equator? If you are closer to equator, troposphere height is more. Yes. Crossing 18 kilometers is very difficult. Crossing 18 kilometers is very, very difficult. That's why we normally go in this, whereas they go in stratosphere. Okay. Yeah. So guys, I will give you notes for this after the break. Okay. Which slides you want? Some people were asking for different slides. Anyways, you get slides, guys. Why do you worry so much? Like, that slide, this slide, anyways, you get it. So that's what you get, all slides. Don't worry about it. Immediately at the end of the class, you get it. Ma'am, ozone is formed because oxygen and O minus, that is molecular oxygen, will join in front of, will join when UV is present. Okay, when UV rays will fall, oxygen plus molecular oxygen will join. It forms ozone. India plain move in troposphere because height of troposphere is 18 kilometers. Going above that is very difficult. Whatever I am writing, those things, if you can write down, it's more than enough now. Nikhil, don't worry. Foreign flights move mostly in stratosphere because height is less. That is only 13 kilometers. Our troposphere height is 18 kilometers. Going above troposphere is very difficult. So normally we go at the height of 12 kilometers or 13 kilometers. Why 18 kilometer in India? You tell me, you understand this? Rakesh, you understand this? In this, you saw 18 kilometers of troposphere. Zarana, you see? Zarana, you see? 13 kilometers. 13 kilometers. 13 kilometers. 13 kilometers means within troposphere. 13 kilometers means exactly stratosphere. 13 kilometers means troposphere. Okay, guys. Take break. We'll meet at 6:44. Anbu, how troposphere is differing? Till now I told the same story. Because of hot and cold, it is differing. Now, if you ask again, that means you were not there when I was teaching. This is syllabus only, guys. All gases are present in stratosphere, but ozone is a new gas present. Yes, yes. You write down stratosphere. Mama, see that at the end now. Stratosphere. Okay. It extends till 50 kilometers. It is also known as ozonosphere because of presence of ozone in brackets. Along with ozone, other gases are present. Next, ozone in stratosphere is considered to be good ozone because it absorbs UV rays from the sun and protects us or protects living organisms. Second point, we are teaching atmosphere now. This is in climatology, first chapter. I'll move to the next slide, guys. Shall I? Stratosphere is good for aircraft movement because no vertical movement of air, there are less clouds. Guys, uh, you tell me now. I have Earth. I have two layers. Troposphere I saw, stratosphere I saw. Okay? Aircraft means aeroplane only, guys. Troposphere means, can I say there is vertical movement, everyone? Stratosphere means no vertical movement. Yes. So Can I say one layer I have vertical movement, another layer I have no vertical movement? Okay, in one layer, if I take A and B, C and D, A is hot, B is cold, C is cold, D is hot. Okay, now I want you people to think and tell, can we say these two layers are completely different? These two layers are completely different. Yes. Then in between these two layers, should there be some transition layer? Should there be some transition layer? Yes. This transition layer is called tropopause. Okay. It is called tropopause. Yes. Can you tell me what is pause here? Pause means something is stopping, correct? Pause means what? Something is stopping. What is stopping in this region, guys? Any idea? What is stopping in this region? Temperature. Very good. So temperature will be constant. In tropopause, we normally see that temperature is constant. Amok, if you have not attended previous session, please see previous session. You will understand why C is cold and D is hot. Clouds are mostly present in troposphere. Okay, now I want you to write third one in the notes. Tropopause. Tropopause. It is a transition layer. Ankita, it is a transition layer, Ankita, between troposphere and stratosphere. So in that layer, what we observe is constant temperature. Okay, it is a transition layer between troposphere and stratosphere. Transition basically means what? Whenever you have two different layers, in between that, if you have any layer, we call transition from one to another. In this layer, temperature is constant. In this layer, temperature is constant. Okay. Now you tell me. Okay, guess why temperature is constant? That's what we observe. Okay, Zarana, you're right. Now, my point is, this is troposphere, this is stratosphere. Okay, in between the layer that is there is called tropopause. Now let me assume that 0, 30, 60, 90. If I say here it is minus 45 degrees Celsius, above also temperature will be minus 45 degrees Celsius. Here if I say minus 54 degrees Celsius, Here also minus 54 degrees Celsius. Here minus 64 degrees Celsius. Here also minus 64 degrees Celsius. That means within troposphere, temperature is constant. Why temperature is constant? We are not aware of this. That is the observation that we make. Okay. So in the transition layer, temperature is constant. That's what we know. Why exactly we are not aware. Over a period of time, it has become like that. Okay. So you tell me, the height of tropopause, is it same or is it changing? Height of tropopause, is it same or is it changing? Changes. Good. Aditya, no, it is changing. 8 to 18 kilometers. You write that point. The height of tropopause is not constant. It changes with latitude and seasons. Guys, after this, the next layer we have is mesosphere. Mesosphere. Okay. Now, if I take no, nothing much. No, Amrit, not any specific part. It is okay. Uh, 0, 8 to 18, 50. Now, guys, in mesosphere, you will have more air particles closer. You'll have less air particles above. As you move above, number of particles reduces. 80 kilometers. A and B. Can you tell me which one will be hot, which one will be cold? A will be hot, B will be cold. Right? More air particles will be hot, less air particles will be cold. Okay. You tell me, if cold is above, hot is below, is there possibility of vertical movement? Yes. Is there possibility of, yeah, mesosphere height is constant. Is there possibility of convection? Yes. But you tell me, uh, will you have, okay, I'll give you one small example, guys. You see, I have a tumbler, very little water is there. I have a tumbler, more water is there. I will heat both. Fire. Okay, I will heat both. Can you tell me where you can clearly see A and B? Where you can clearly see that there is vertical movement, where it is not visible? Can I say B we can see, A we cannot see? Yes. Can I say A is less convection? B is more convection. Mesosphere doesn't have much air particles. Okay. Now you tell me in this, as I go above, you tell me in atmosphere, as we go above, will the number of air particles reduces or increases? Number of air particles reduces. In mesosphere, will you have more air particles or will you have less air particles? Less. If you have less air particles, will you have more convection or less convection? Less. Do you understand? Mesosphere. You write along with me? You write along with me? We have a transition. Yes, I'll come to that. Mesosphere. In this layer, sorry, temperature decreases with height due to density of particles. There will be very less convection because there are less particles. Amrit, stratosphere is not because of density. Stratosphere heat is because of ozone. Okay, in stratosphere, it is because of ozone. Ozone is the main culprit. Okay. Yes, we see more convection in troposphere. NCRT gives the term, guys, convection is present only in troposphere. Huh. Vinod, Amrit Tandal, remember, in stratosphere, density is not the problem, it is ozone. Ozone. And sun's rays, when it falls, ozone absorbs it. And presence of ozone is causing this problem. If ozone is not there, then stratosphere would have been similar to troposphere and mesosphere. Because of ozone, you are seeing it differently. Guys, I'll tell you a very simple thing. Two types you will get heat. Okay, heat you will get because of two reasons. One, when more air particles come closer, temperature increases. Okay. Second, if you heat it from outside, temperature increases. Two reasons. What are the two? If more air particles come closer, temperature increases. Second, what is the main aspect that you are trying to think? If you heat it from outside, temperature increases. In stratosphere, we are heating it from outside. In troposphere and mesosphere, it is particles coming closer. Why ozone is there only in stratosphere? We don't know actual reason for that, but that is an observation, guys. That's a fact. Okay. Why only in that layer? We don't know. And in mesosphere, temperature will become minus 80 degrees Celsius. Okay, in mesosphere temperature will become minus 80 degrees Celsius. So it is coldest layer of the atmosphere. Gravitation is very less, guys. Anjali, you have to tick both troposphere and mesosphere. Guys, mesosphere is the coldest layer of the atmosphere. Okay, mesosphere is the coldest layer of the atmosphere because in this layer temperature will become minus 80 degrees Celsius. Now I have a question to you guys. Think and tell. Near the poles, if we go near the poles, will temperature be extremely cold near the poles? Yes. So if temperature is extremely cold, okay, if we go there and if we rub our hands like this, you tell me, due to friction, will heat be generated? Dhruv, yes, there will be negligible particles. Yes. Heat is generated? Yes. Heat is generated due to surrounding temperature or is it due to friction? Heat is generated due to surrounding temperature or due to friction? Due to friction. Okay. Similarly, in mesosphere, due to friction, we observe meteor burning. Meteor burning. I'll explain what is meteor, guys. Due to friction, we observe meteor burning. Remember, meteor burning occur in mesosphere. Okay, I'll explain what is meteor. Is this slide completed? Can I move to the next slide? A layer is hot means, okay, everyone has a very common doubt. I'll just explain this. I'll explain meteor. Wait. 100 degrees Celsius, 60 degrees Celsius, 40 degrees Celsius. Okay. Yes, among these three, which one is hot? Among these three, which one is hot? 100? Common sense, 100? Yes. 40-degree? Is cold. Good. What is 60 degrees? What is 60 degree? Not normal. Is it hot or cold? 60 degree, is it hot or cold? Can I say 60 degree is cold compared to 100 degree? Can I say 60 degree is cold compared to 100 degree? Yes. Can I say 60 degree is hot compared to 40 degree? Yes. See guys, when I say A is hot, B is cold, okay, When I say uh, C is cold, A is hot, the meaning of that is comparatively it is hot and cold. Do you all agree? Okay. So it is comparison. Comparatively, it is hot and cold. Okay. Yes. Now, you see, we have sun, planets are there. Okay. Now, the first four planets are called as inner planets. The next four planets are called as outer planets. These two are separated by what we call as asteroid belt. Okay, guys, asteroid belt basically means it is believed that once upon a time there was a planet here, okay, where asteroid belt is there. In that region, one planet was there. Something hit it and it broke into smaller particles. So this is also revolving around the sun. Okay, the way Earth is revolving, the way Mars, Mercury, Venus, Earth, Mars, even asteroid belt is revolving around the sun. So this asteroid belt, where is it present? Asteroid belt. Okay, this asteroid belt is present in between Mars and Jupiter. In between Mars and Jupiter. It is present in between inner planets and outer planets. It is present in between terrestrial, Earth-like planets and Jovian planets. Okay, this is prelims question, guys. Okay, please know this. Asteroid belt is present in between these. Okay, now you see. Now you see here in the solar system, here and there, Lakshmi, just now I told it is broken pieces of rocks present in between Mars and Jupiter. Now, in the solar system, you still have some broken rocks floating. Okay, so there are some broken rocks floating in solar system. Okay, guys, these broken rocks are not asteroid belt. They are not present only in between Mars and Jupiter, but it is floating at different places. This broken rocks floating in the solar system is called meteoroid. Okay, the broken rock floating in the solar system is called meteoroid. Do you recollect in the beginning planetesimals joined to form molten magma? Do you recollect in the beginning all the planetesimals joined? So some planetesimals are still present. Okay, that is called meteoroid. Okay, So broken rocks floating in the solar system is called as meteoroid. And when these broken rocks, enter into Earth's atmosphere, when it enters into Earth's atmosphere, it is called as meteor. Okay, if this enters into Earth's atmosphere, it is called meteor. What is meteor? Meteor is meteoroid in Earth's atmosphere. In Earth's atmosphere. Okay. When this meteoroid hits the earth, it is called as meteoroid. Whenever it is hitting the earth, it is called meteoroid. Manpreet, good. So no, I'm not muted. Okay. Can you see 3? Can you see 3? What are the 3 terms? Meteoroid, meteoroid, meteor, meteoroid. Gaurav, yes, it is true. Debris is there. Okay. Do you all understand the 3, guys? Do you all understand the 3 terms? Yes. Can you tell me, meteor burning is mostly present in which layer? Meteor burning is mostly present in which layer? Mesosphere. Mesosphere. Now you write, when meteor burns in mesosphere, it may have water vapor. It may have water vapor, and it would form clouds. It would form clouds. These clouds in mesosphere is called noctilucent clouds. Shooting stars. That is also called shooting stars. Rakesh, meteoroid means if anything left in the meteor, if it comes and hit the earth surface, we call it as meteoroid. Ma'am, Anjali, in case if water vapor is there, it may form a cloud. In case, okay, that cloud is called noctilucent cloud. Ma'am, meteor burning in the mesosphere is called as shooting stars. Anuradha, you tell me, is mesosphere hottest area or is it coldest area? coldest. Oxygen lit. Okay. Hayat, burning is not because of oxygen or something. Burning is because of friction. And yes, oxygen is there within mesosphere. Oxygen is not there above mesosphere much. Okay. Guys, note what is meteoroid, broken rocks in solar system. Below particles are less, so friction will be there. It's not like friction is absent. That friction is enough to burn. Ozone and all is not present much. Anuradha, meteor burning doesn't happen every day. Friction between meteor and gases. Whenever you burn crackers, for some time heat will be there, but after that it will normalize. Similarly, mesosphere also, whenever meteors will burn, some changes will be there, but after that it normalizes. Meteor is meteoroid entering into Earth's atmosphere. Meteoroid, meteor hitting Earth's surface. Yeah. Tanvir, nothing much. Manasvi, you tell me. Mesosphere is made up of oxygen and nitrogen. 99% is oxygen and nitrogen. So you tell me, if you have 99% oxygen and nitrogen, does it absorb sun's rays or earth's rays? No. Yes. So it is not under the influence of the sun. Guys, very important topic. This will be taught in science and tech for you. Manasvi, please see the notes once and then come back, because you're getting confused. Oxygen and nitrogen doesn't absorb Earth's rays or sun's rays. Okay. Anyways, this, are you done with this? See guys, when you listen to class, most of the topics you feel comfortable. But if you don't revise, you will be confused and you keep asking questions in a wrong way. Okay. After teaching basics, again, if I have to go back and tell you, carbon dioxide doesn't absorb sun's rays, carbon dioxide absorbs earth's rays, oxygen, nitrogen doesn't absorb sun or earth, we are losing out time. You also get confused. Okay, please read. Please read multiple times and come to class. Next 1 month, if you can sit with me, I will ensure that you get 14 to 15 questions accurately in geography. Not only in UPSC, any Indian exam you take, you will get maximum marks in geography if you can read multiple times the class notes and come. Okay. Now, now, guys, what is the last layer left now? No, no, no. We have one more layer. What is that layer? Thermosphere. Okay. Guys, before that, we have a layer called as stratopause. Okay, stratopause. It is transition between stratosphere and mesosphere. It is transition between stratosphere and mesosphere. The height is fixed at 50 kilometer and doesn't change like tropopause. Do you recollect tropopause height changes? Here height doesn't change. Then you also have a layer called as mesopause. Through pause is used because temperature is constant. Mesopause. It is at 80 kilometer and it is transition in between. It is transition in between mesosphere and thermosphere. Mesosphere and thermosphere. It is in between. Yes, ma'am, it is also constant. Do you recollect I told you something called as homosphere and heterosphere? Yes. Guys, are you people understanding the classes? I am going in greater detail, but the factual data, facts, concepts. Okay. Guys, if at all you have attended previous classes, you will not have doubts in these. If you are not understanding these classes, one, language issue. Some people were telling they are from rural background. They know only Kannada, they know only Hindi, they know only English. Then definitely it's a problem because I'm talking only in English. right? And terminology issues will always be there in geography if you are not from that background. Second, if you have not attended previous classes, there is no chance that you will get clarity in these classes. Saturday, Sunday, you will have time. Please revise properly. If you have not seen, see these videos. You will get a lot of clarity. See them. With respect to notes, whatever I'm writing, it should be there in your notes, guys. Okay. It should not be like I will take printout and read. I want you to write along with me. See, any topic, if I teach you and if I leave, you will forget. If I teach and make you write, it would be easier. Okay. Next week onwards, you will have like uh, tests and all. Don't worry about tests. Don't be so much worried. First, let's move slowly. Read it. Don't try to read again. Mesopause is in between mesosphere and thermosphere, homosphere and heterosphere. Okay. After every layer, transition is there for sure. Now, everyone, guys, in 6th standard NCRT, there is a problem, guys. So first I'll explain and then I'll tell what is the problem. See, I have 0, 8 to 18 is troposphere, 50 kilometer is stratosphere, 80 kilometer is mesosphere, till 1600 kilometers I will have a layer called as thermosphere. Okay. Within thermosphere, if I take 400 to 600, okay, if I take 400 to 600, this will be called as ionosphere. This will be called as exosphere. Okay. 80 to 400 or 600 is called as ionosphere, till 1600 is called as exosphere. So thermosphere is divided into two layers. 6th standard NCRT says that troposphere, stratosphere, mesosphere, thermosphere and exosphere. That is not correct. The topmost layer is thermosphere only. Within thermosphere, you have ionosphere and exosphere. In case in exam, if they give, which is the topmost layer of the atmosphere, then you can give exosphere. If they ask you arrange in order also, troposphere, stratosphere, mesosphere, ionosphere and exosphere. Okay, this order should be clear. Many times they have asked this question. Oh my god, Lakshmi, I don't know, between tropopause and stratopause, within stratosphere you have ozone. I don't know why you lost this completely. All like pause layer is constant except tropopause. Okay, I'll explain this, don't worry. So what are the layers I have here? Now let me only talk about ionosphere. We normally consider 4 layers. All standard books talks about 4 layers. Okay. You see here, let me say this is 80 kilometer. 0 to 80 kilometer. Okay. Now everyone, till 400 to 600 kilometer, I have a layer called as ionosphere. No, ma'am. Don't worry. I will tell you what to write. Don't worry about that. Ionosphere. Guys, in ionosphere, we have lot of ions. Okay. We have lot of ions. Ions means charged particles. We have lot of charged particles. And what is the beauty of this charged particles, guys? If you see, now whenever you send radio signal to them, okay, it will hit not electrons, charged particles. It will send back the signal to us. This is helpful for radio communication. Have you seen before, like, when you had TV antennas and all, people used to go above and turn the antennas here and there to get proper signal? Yes. Nowadays, have you seen in the car and all, the, like, antenna is very small? Can you see nowadays it's very small? Yes. Huh. The reason for this now is we normally have replaced in this region satellites. Rather than using the ions, just check once, okay? Rather than using the ions, we normally use satellites now. This satellite is called as low Earth orbit satellite. Okay, low Earth orbit satellite. In which layer it will be there? Ionosphere layer it will be there. Yes, we send satellites above 80 kilometers. Okay. Have you heard we are planning for Gaganyaan? Gaganyaan? Yes. Gaganyaan will be sent into ionosphere. Ionosphere. Okay. Yeah. Now, beyond 400 to 600, beyond 400 to 600, we will have exosphere. Exosphere. And in exosphere, particles will be very far from each other, it seems. It is said that the distance between two particles will be more than 100 kilometers, it seems. Very far from each other. And it merges with outer space. It merges with outer space. Okay? This is enough. This is enough. I want you to write along with me. Thermosphere. Guys, aurora borealis and all is different concept. I'll explain you that later. We have it. We'll explain later. Thermosphere. It is above 80 kilometers and it extends till 1600 kilometers. Extends till 1600 kilometers. In this layer, particles are far from each other. Temperature is negligible. Temperature is negligible. Guys, what is temperature? Temperature is degree of hotness or coolness of a body, correct? Temperature is degree of hotness or coolness of a body, correct? If air itself is not there, will you have temperature? If air itself is not there, will you have temperature? No. So temperature is almost negligible. Yes. Now you tell me, whenever two particles come and hit, is there possibility of friction? Is there possibility of friction in case if it hits? Yes. Will it increase temperature? Will it increase temperature? Yes. So in thermosphere, temperature is observed only when two particles hit. Else temperature is negligible. Okay. Then you write thermosphere is divided into thermosphere is divided into ionosphere, where ions or charged particles are present. Where ions or charged particles are present. They help in radio communication. In this layer, Kamalpal, mesosphere is coldest, stratosphere is not hottest. I'll give you temperatures, you'll get to know. In this layer, Vishant, no need of those. Low Earth orbit is present. Dhruv, this is science and technology, you can ask there. I can't enter into those much. In this low Earth orbit, satellite is present. Can I move to next slide? Ionosphere extends till 400 to 600 kilometer. Exosphere it is topmost layer And here we observe very less gases. It extends till 1600 kilometers and merges with outer space. Good. Done, guys? Now you see, guys, in thermosphere, temperature is actually negligible. But when two particles hit, there will be friction. And due to friction, heat is generated. This heat will be thousands of degrees Celsius. So people normally say that whenever heat is there, thermosphere will have highest temperature. You tell me, is wind always stationary or will it move? Will it move? When it moves, it hits. Yes, they hit each other at very, very high speed. Correct. Why? Friction. Ankita, friction is the reason. Okay. Guys, everyone, we have less time. I want you to uh, draw a diagram along with me. Yeah. So highest temperature is there in thermosphere. If at all friction occurs. Not always, yes. Only when friction occurs. Please write along with me. See, guys, stratosphere temperature at the bottom will be minus 54. As we go above, it will reach 0 degree. Troposphere near tropopause, average temperature will be minus 54 degrees Celsius. I'll come to lapse rate and all later. Yeah, this is the diagram you have to draw in mains. Oh, Dhruv, don't get into that. You can draw like this also. Becomes thousands. Data is not fixed, it changes, but mostly you can say it's fixed. Sai Dinesh, very high temperature, mainly because of friction, hitting of the particles. A sixth standard NCRT, if you see, precipitation, PRECIPITATION, radio communication or satellite. Please see sixth standard NCRT book. You will get aeroplane in stratosphere. They will give meteor burning in mesosphere, satellite in ionosphere. Yeah, meteor burning or shooting star, both are same. Okay. Please draw this. In exam, this should be there. Structure of atmosphere. No, there is no layer between ionosphere and exosphere. Please draw my diagram. That's fine. Today's class, 6th standard, 7th standard, 11th standard, all three. Huh. Kamal Pal and others, I want you to tell me, meteor is burning due to surrounding temperatures or due to friction? Okay, that is the answer. So meteor is not burning in ionosphere because friction is less. Done, everyone? Shall I move? Yes. I want to ask you only one thing. I want you to know only one thing, guys. In the entire thing, if question is asked about structure of atmosphere, okay, first you have to write all the layers, guys. In the layers, you have to write height and you have to write temperature. Okay, this is for mains. Application, meteor burning and all, is for prelims. Okay, and guys, I just want you to know another thing, one technique for you. In geography, numbers is never fixed. It changes from book to book. Every book will have its own numbers. My numbers will be different, some other numbers will be different. If you want, you check 6th, 7th standard NCERT book numbers will be different. Okay, everywhere you will have different numbers. Okay, so UPSC numbers is always wrong. Okay, UPSC numbers is always wrong. Any statement in UPSC with the number is always wrong. Like, while solving previous year questions, I will show you them. Any number you take, it is always wrong. Ankita, please see. Huh. Aniket, here I gave you, you see, minus 54 degree, 0 degree, minus 80 degree. This is what you have to write. Kamalpal, we will do this later. Why it does. Rockets and all will be affected. Rockets, we know the rocket will have a friction which is always in such a way that it will not affect it. Rockets are made in such a way that it can withstand the friction. Hottest layer is thermosphere, coldest layer is mesosphere. Zarana, what is the question? Thousands of degrees Celsius. Above mentioned, I didn't see, ma'am. Sorry. Yes, Abhishek, you're right. The curve is stratosphere. Hottest layer is thermosphere. Chandru, it is due to friction. Just imagine when two particles hit, it creates friction. Okay, Kavi, ma'am, everyone, please understand. Thermosphere doesn't have temperature. If you go there, no temperature, you don't feel anything. Only when two particles hit, if I go and keep thermometer there, I get thousands of degrees Celsius. Okay, that's it. Okay, no need to make any other notes, guys. I think this is enough. If you're reading NCRT, if you get new points, you can add. Fighter jets and all will be mostly in stratosphere. Aniket, these things you can Celsius, centigrade and all you can see. Okay, guys, thank you. Thanks a lot. We'll meet on Monday. Uh, okay, work for you for this weekend is please read notes again and again. I'm telling you, because over a period of time we will be applying same concepts. Thank you.